Hi, welcome to Raw Math. Today I'm doing a series of videos on inverse functions. So we're going to start with consider the function f of x equals the cubed root of x and the set of inputs 0, 1, 8, 27, which yield the outputs 0, 1, 2, 3. So if we put in 0, we get 0. If we put in 1, we get 1. If we put in the cubed root of 8, we get 2. And if we put in the cubed root of 27, we would get 3. We're going to write this as a set of ordered pairs. Set means that we're going to use curly brackets. An ordered pair just means we're going to write them as ordered pairs. So we have curly bracket 0, 0, parenthesis 1, 1. Input of 8 gives us 2. Input of 27 gave us 3. All right, so that set meant curly brackets. Now we're going to interchange the coordinates. That means I'm going to reverse them. So I'm still going to do set notation, but what I'm going to do is I'm going to interchange my zeros to make it 0, 0. And I'm going to interchange my ones to make it 1, 1. And I'm going to interchange my next set to make it 2, 8. And I'm going to interchange my 27 and 3 to make it 3, 27. Still keeping it in set notation with the curly brackets. All right, so what we just did is something called the inverse of a function. So f of x has an inverse denoted by f negative 1 of x. Now, that negative 1 is not, a lot of times that negative 1 means we make a fraction. That's not what this is. This is called f inverse. So some notes. First one, which I just gave, is that f negative 1, f inverse of x, is not 1 over f of x. No, that's something different completely. B, and this is a big one, big. The domain of f inverse of x is the range of f of x. Kind of fun. And the next one is the range of f inverse of x. Can you guess? Is the domain of f of x. If we're reversing our ordered pairs, that means we're reversing our domain and range. So one last fun bit of facts. What we did before is we said that f of x was the cubed root of x. As it goes, the inverse of that, if we looked at our ordered pairs where we went 1, 1, 2, 8, 3, 27, the inverse is x cubed. Just fun fact. And so what we're going to do is we're going to do a few compositions. This right here, where you put a function as the input of another function. This right here, this is a composition of functions. I have videos on that. And so what I want to do is I want to find the composition of these functions and see what happens. So if I find f of f inverse of x, in other words, I want to put this x cubed into the x of this. So I want to find f of x cubed. So I want to find the cubed root of x cubed. That's going to equal x, because they undo each other. As it goes, they are inverses. And then I'm going to do the other one. I'm going to say the inverse of the function, is going to be putting the cubed root of x in here. Well, that's going to equal the cubed root of x cubed. This will also equal x. And this right here is our test. This is, by definition, how we can test for inverse functions. So an inverse function is when we can find the function of an inverse in the inverse of a function and it equals x. Then we know for a fact that we have inverse functions. All right, I hope you enjoyed this video. Please subscribe to my YouTube channel and I'll see you on the next video. Thanks.